2:01. We're going to start early today. How's that sound? Let's do it. I totally believed that enthusiasm. So how many of you are feeling kind of sad because the weekend's coming and you think you'll be bored and you want something to do? Is anyone feeling like that? No? Well, guess what, folks? Just in case, you have two things you can do. Number one is your first formative assessment in Icon under quizzes. Get that done by Monday night, please, so we can talk about it on Tuesday. Remember that you get your 2 points for doing it, okay? I don't care how wrong it is. This is your opportunity to test out what you're learning. Try to do it yourself, and if you need to consult your notes, that's fine. I do need to explain the last question. Did I talk about that yet with this class, or was that my other class? I think it was the other class, but I'm going to keep doing this all semester. So the last question of your first formative assessment, did it already? Good work. Is a different kind of question. I want to know your theme song. This is a get to know you question. So let's picture like you're playing a sport, right? You're going to enter the Super Bowl next week or the World Cup or whatever. And when you come into the stadium, there's a song playing overhead, right? What is it? That's what I want to know. Any song, any language, I don't care if it has profanity. And if you're willing to share, put a link to it on YouTube in your answer, and I'm going to build a class playlist and send it to you so we can all share each other's theme songs. It's a fun way for me to get to know you and get some new music in my life. I used to say that there were no incorrect answers to this, but then someone wrote down Christmas music once, and I'm sorry, I cannot accept that. Silent Night is not playing in the arena when you enter the Super Bowl. It's just not. I went to a minor league baseball game last summer where I think the opposing team was being harassed by the theme songs. Like they were playing like 70s easy listening music as the other team went up to bat. And you really just can't get pumped when you hear like Easy Like Sunday Morning coming on. You know, that's not a go up and kill it kind of song. So I was very amused by that, but I'd like to hear about your theme songs. The other thing that you can be working on that I just released this morning is your first homework. So that you have about a week and a half to do. You should be able to start the first, so it's 3 different models. The first model is an empty model. So we talked about that very briefly, but just to remind you, how do I take this code right here that's in front of me in Stata and turn it into an empty model? Like, get rid of all that. Okay, that's it. In R, how do I take that code and turn it into an empty model? Let me get some R code up here. Like that model right here, how do I turn it into an empty model? Yeah, delete all of that. Okay, that's your first one. The very first question to each of the models in your homework is going to ask you the residual variance. The reason that is being asked first is that if you get it right, you have the right model. If you don't get it right, your model is not right and you cannot answer the rest of the questions. The next question is going to be, what is the fixed intercept? If you get that wrong, but your residual variance is right, that means your predictors are not centered correctly. You do not have the right reference point for what your fixed intercept represents. So those are troubleshooting questions to help make sure that you're in the right spot to be able to answer the rest of them. So the first model is empty. The second model is main effects only. We've talked about that. So we're getting ready to tackle the third model with interaction terms. So we'll do that today and probably next time too. So you're welcome to get started on that. I also highly recommend my homework if you want to feel productive but you don't want to write or do anything else that is amorphous and challenging, right? Because then you can still say you're doing work, you're just not doing the thing that you don't want to do. And I know that because I often do classwork instead of my own writing. So I'm just as guilty of that as anyone else. All right, so questions on any of that? Are we doing okay today? I feel like everybody's kind of... Is it me? No? It's just week 3 and like reality is hitting? I'm there with you, folks. I'm right there with you. So as promised, I said that we could re-go over this, right? Pretend like it never happened? So let's do that. I'm on page 6 of example 1, and we're going to tackle ourselves some interactions and simple slopes and regions of significance. So do you remember the story behind these fake data based on real data? These are fake old people. We are predicting their status on a measure of cognition from their chronological age in years, centered at 85, their grip strength, centered at 9 pounds per square inch as a proxy for physical functioning, a binary variable for gender, in which men are the 0 and women are the 1, and then a 3-group variable for dementia status. So I have created 2 contrasts by which to index that. I have dementia none versus future and dementia none versus current. So that means that none is going to be my reference group. Your homework has 4 groups, by the way. So if you know how to do 3, you can figure out how to do 4. And then to answer the question, to what extent does the effect of age on cognition depend on grip strength? Or to what extent does the effect of grip strength on cognition depend on age? We have in our interaction term. So if I go through the equation here, which of these betas that we had before is going to change its interpretation relative to the model without this interaction? So you can just tell me yes or no. Yes is going to change. Is beta 0 going to change? What it means after adding in this new interaction term. Is beta 0 going to mean something different than it did before? Got 1 vote for no. Zoomers, you going to vote? The roomers are just staring at their laptops. They don't want to vote. Vote! What do you think? Is beta 0 going to change interpretation after adding this interaction term?
No.
No, it does not. Yeah, you know this. Don't be afraid. It's better to be wrong than vague, a professor once told me. I like that. No, because the intercept is conditional on your predictors being 0. We have not introduced new predictors, just a new term involving the same predictors. How about beta 1, the slope of age? Is it going to change relative to what it was before in terms of what it means? Yes, it's conditional. Beta 1 is only the slope of age after the interaction term drops out, and that happens if grip is 0. So therefore, beta 1 is specifically the age slope for grip 0. Likewise, beta 2, going to change or not? Going to change, same reason. This is the grip strength slope when age is 0 and the interaction term drops out. Gender effect, going to change what it means? Yes or no? Nope, this is still marginal or unconditional. This is the gender gap regardless of your age or grip or dementia status. Likewise, dementia slopes, going to change or no? Nope, they are unconditional with respect to everything else. So we did walk through a little bit of output last time. We did through the list here. I'm going to do the R output instead this time, try and make it more fair. So we'll start with R and then I'll work my way back to this data. Okay, so I'm scrolling down a bit to get to the same model in R, which is on page 8. And by the way, this is straight out of chapter 2 from my longitudinal book that is on your reading list. The reason why a chapter from a longitudinal book is on your reading list for this class is that I realized that if you don't understand interaction terms, you will not be able to get very far on longitudinal models. So I wrote a whole chapter just about interaction terms and regression because most people have not had good coverage of that when they came to see me. So that's why. But this is straight out of that. So here's the same equation. Here is my linear model call. Note that I am adding age grip interaction with a colon. So that's adding a two-way interaction. And whether you want it to be there or not, R is going to reorder your fixed effects to put it at the end. I did not want that to happen, but it does. So just a heads up on that. So now we can go through the list and talk about what is happening with our new interaction term. So let's talk about the slope of age with grip as the moderator. We did this last time, so you might already know the answer. Which pattern is this? Grip strength is doing what to the age slope via the interaction term? Your choices are making it more positive, more negative, or less negative. Less negative, yes. So is the slope of age getting stronger or weaker in people who have higher grip strength? Weaker. It's getting closer to 0. Eventually, after it crosses 0, it would be then getting stronger, but you're probably extrapolating past the data at that point. So more positive or more negative means the slope is getting stronger. Less positive or less negative means it's getting weaker as the moderator goes up. If we try to put these numbers in a sentence, so the age slope is minus 0.33, specifically for what kind of person? Let's get everyone talking again. Grip strength. Yeah, I think you answered that last time too, didn't you? Because I didn't hear you, but I heard you this time. See, I'm learning too. So this is for grip 9, specifically. That's where 0 is. And then what does the interaction term do to it? How do I put the 0.12 in a sentence? Zoomers, you can play along too. You can either talk, they can hear you, or you can type. Put the 1.12 in a sentence is my question. Am I going to have to cold call on people? I don't like doing that. I once had someone that stopped coming to class completely. And so I sent them an email after a month or so and was like, hey, what's up? And they said they had anxiety so much that they were afraid to get called on that they didn't come. And so I said, I'll make you a deal. I will never call on you again if you come back. And they did, and I held my deal. So if you want me to make that deal with you, I will. You can tell me about it in private. But until then, I might have to cold call if no one's going to talk to me. I'm going to cold call. We're going to start over here. Give it your best shot. Put the 0.12 in a sentence. I'm sorry? I'm sorry, I can't hear you yet.
Sorry, can you ask again?
Ask again. Okay. So I am interested in interpreting the interaction term as describing how the age slope is the predictor and the grip strength is a moderator. So I've highlighted the two numbers that would be involved in your interpretation. So the interaction term is describing what happens to the age slope. Want to phone a friend? So you can cold call on others too. Okay, Sarah, I think she's looking at you.
I got cold called last
I
time.
know, and
It's
you're like,
okay.
I'm not your friend.
I'm gonna try it.
You're gonna try it. All right.
I'm trying to write it. For like each additional year of age, cognition is like negative 0.33, but it's better by 1.123.
Okay, so we're heading in the right direction. You did the opposite pattern.
Okay.
So you put age as the moderator in the sentence rather than the slope. So if we start with age as the slope, just this number right here. Okay, do that one. Minus 0.33 is the age slope.
Okay.
Here, I'll make it, oops, I'll try to make it bigger if I can. There we go. So start your sentence again. You said for every year of age. That part was okay.
Yep. For every additional year of age, is it still cognition?
Yep, cognition's the outcome.
Cognition is negative 0.33.
The lower by.
Lower by, okay, yeah,
Mhm.
lower by 0.33, negative 0.33.
Okay, and that is in people with a grip strength of 9 specifically.
Okay.
Now, what happens to this slope as a function of the interaction term?
It gets less negative,
Less negative by
0.123.
per,
Per 123?
no, per unit what?
Oh, okay. Per, like, pound.
Yes!
Okay.
Sorry, I was gonna point at the output.
Yes,
Thank you.
exactly right. We got there.
Okay.
So the age slope becomes less negative by 0.12 per unit of the moderator, the other variable, which is grip strength. So the interaction term does not operate directly on cognition. It operates on the slopes, which then operate on cognition. That's the tricky part.
So anyway, eventually the cognition score would be lower. That's the eventual conclusion, right?
It would actually be less lower because the age slope is negative, but then in people who have a stronger grip strength, the slope would be less negative, less of a decline.
So it is anyway weak, but still goes on to still explaining the cognition outcome. I mean,
Yes,
yeah.
because the age slope it explains cognition.
Mhm,
So
mhm.
we're
Oh,
just
got it.
tweaking the slope that then finishes the job.
Okay.
Yep, yes indeed. You want to go the other way? We've got a pattern now. We've got a template we can fill in. Grip strength slope is 0.62. Let's do that one. Should we work our way on this side of the room? Tell me your name again.
Kendra.
Kendra, okay.
Okay, so for every grip year.
We're doing grip,
Oh,
so
grip,
for per
okay.
pound.
So for every pound of grip.
Yeah, pound up, you can squeeze on the thingy.
Yeah. So for every pound, grip increases by 0.62.
Cognition is increased by 0.62
Cognition is increased by 0.62.
in what kind of person?
In a person whose grip strength is not.
Other one?
Oh, a person whose age is 85.
Yeah, because the predictor slope
Oh, right.
is conditional on when the interacting variable, the other variable, is 0. Because that's when the bottom one drops out, and then grip 9 is only active. So yes, for every pound of grip strength, cognition is lower by 0.6 in people who are 85. Okay, so then the question is, what does the interaction term do to it from this perspective? If the slope is positive for grip strength and the interaction is positive, which pattern is this? 4 choices.
More positive.
Yeah. So now we got to put the 1, 2 in a sentence going this way. So I would start with, for every unit of the moderator, for every year of age, this slope, grip strength, becomes more positive by 0.12. Or the grip strength slope becomes more positive by 0.12 per year of age. You want to go that way. Nikki or Vladimir, anything to add? Other ways to say it?
It's hard to come up with alternatives when you are the one who taught me.
Okay, I'm going to rephrase the question. What's the follow-up sentence after that one that you need to give your reader so that they can highlight it? Putting it into plainer terms. Conceptually, what does this pattern mean?
Is it that for every additional pound of grip, your cognition basically will get better, and even better if you're younger?
Even better if you're older, actually. But yes, I like that. Even better. Yeah, the benefit of grip strength is enhanced in older people.
Oh, okay.
That's what more positive means. So these sorts of interaction hypotheses are often phrased as like risk factors kinds of things or benefits. So something getting more positive is like a stronger benefit at higher levels of the moderator. Age getting less negative as a slope would be like mitigating risk, like a protective factor, people sometimes say. Like aging is bad for you, but it's not as bad for you if you're stronger. That's the idea of a protective factor.
I have another example from
Hit me.
my work. So, as I mentioned, I'm studying like comprehensive support programs for students. Not everybody participates in those. So, like, participation matters for everybody. It's a benefit, right? So that's the idea of the simple slope of like participation matters, but participation matters above and beyond for low income people of color, different things like that. There's like an added benefit above and beyond just participation for those groups of students.
That's good. So the effect is strengthened in those people with those characteristics.
And our outcome is usually some form of academic outcomes of GPA, persistence, retention, graduation.
See, and I like that example because participation matters, right? Okay.
Lisa, I have a question there. What was the opposite term? I mean, you were using enhanced or strength to use more positive slope. So what was the other one? Like trying to, when we are trying to describe less negative?
Less negative, I would go with the effect is diminished.
Diminished,
The effect is weakened.
weakened or diminished.
If you had something that was more negative, I might go with exacerbated, like it's bad for you and it's more bad for you if it's more negative as the moderator goes up. Exacerbated is usually a bad word, it seems like. Yeah, you can pick out all your favorite GRE vocabulary words to describe these things. And it's significant. So now we got to think about what this would imply for our sample. Like who is going to have a negative age slope? And at what point does this cross over to 0? So as grip increases, right, this is going to come, it's negative, so get my number line from your perspective here. It's heading this way towards 0. Eventually it's going to cross 0, right, as you keep going up and up and up, and then it's going to switch to become a positive slope. So when does that happen? Is there a point on grip at which age is actually good for you? The model implies that could happen. Likewise, grip strength is good for you. It keeps getting more good for you as you get older, in older people. So that implies that it is not as beneficial in younger people. At what point does it not matter? So people often compute what is known, unfortunately, as simple slopes at particular values of the moderator to try and get a sense of it, and they make a picture. We can also do regions of significance to try to figure out where the boundaries are when these effects turn on and off in different directions. So we can try to do that. All right, we did most of those. Now, asking for extra stuff is the next portion here. Not relevant at the moment, but we can ask for a complete picture from this model, the missing implied difference between the two dementia groups. We'll do that in more detail in just a minute. We can ask for custom F-tests to lump the two groups for dementia together. We can ask for custom F-tests for anything. So I did one just as an example here. What is the joint contribution of age, grip, and their interaction? I can get a hypothesis test for that. Now let's talk simple slopes. Do you remember the rules? 3-step process. So if I want the age slope from my equation, step 1, find all the terms that have age in them. Bring them down. So I've got just these two pieces, right? These are the only things that have the age slope. Step 2, factor out age because that's the variable that you want the slope for. What's left are the ingredients to get your simple slope, and that's what you tell your computer to do. So beta 1 as the age slope times the plus the interaction times the moderator is how we get the age slope at any level of grip. We can do the same thing for the grip strength slope. So we start with the main effective grip and the interaction, factor out grip, and then what's left is how we get the grip slope at any age. So down here, I am using these are my ingredients. Now I'm going to cook myself some simple slopes. So first, I'm asking for 3 age slopes. Do you remember what the blue numbers do? They're multipliers. How do I know what order to put my numbers in? The order of terms in your output. So you need to look back at your results, and the order in which they appear is the order in which you write your multipliers. What they are multiplying are the fixed effects in the solution, not the variables. So if I want an age slope, I don't need my fixed intercept. That's first. Note that in all of these examples where I'm asking for a slope of some kind, they stay 0 in the first spot. The intercept will never contribute to a predicted slope. However, in the first 3 lines, we get a 1 in the second slot because I need 1 beta 1. Then I'm skipping over the main effective grip, the sex difference, and the dementia differences. And then in the last spot is this term right here, beta 6 times grip. So the number that goes in here is the value of the grip moderator that I want the age slope for. And I said I want grip strength of 6 because that is roughly -1 standard deviation, so that's like a typical low value. So if I want 6, why did I put -3 here? Because it's centered at 9. So this is a very common mistake, is people put in the number they want, forgetting about the centering. It has to be relative to the centered variable. So the first line is going to give me an age slope for grip at 6. The second one is going to give me the age slope for grip 9. And the third one gives it to me for grip 12. Now note this line right here. Did I really need to write that? Did I need to write that one? Anytime that you look at your list here, and if there's only a 1 in one spot, you didn't need to write it. I did it for transparency so you could see the pattern. Now, if I didn't need to write it, how am I going to get this one? Why don't I need to write it? Yeah, it's just beta 1. It's already in my output. Going the other way. Here's how I get the grip strength slope for any age. Note the pattern. Now beta 2 turns on in each case with the 1, and then the value of grip strength, or age, excuse me, that I want the grip strength slope for, I did 80, 85, and 90. So this is the long way. This allows you to get linear combinations of your fixed effects of any kind that you need. It's very flexible. If you're like, can I not type that much and do this faster? Isn't there an R package for that somebody wrote? Yes, there is. There's a package called Simple Slopes. You know what my package would be called? Hard Slopes. Complex Slopes. So it's in Reg Helper is the package I found. This is the function. And what it wants is a list of values that you want as the moderator. And it took me a few minutes to figure out, but you have to add this, and that's what you get, Simple Slopes Test. And so I get the exact same output that I got from here with less typing. So if you want to use that, you can. However, this does not work for non-linear models from what I remember. It only works in certain types of models and it won't work in generalized models. So we got to know how to do it the hard way. All right, so this is the linear hypotheses that I did. Note my labels in here in green. Future me is very happy when I label things well the first time. So do that to yourself. And here's the results from their version, which is a little less transparent, but they match perfectly. So let me get a picture for you. We'll go back to, actually, let's do the Stata version for this real quick, and then we'll do the picture. Okay, so I'm backing up to do the same exact simple slopes the Stata way. I'm on page 7. So I wrote out the equations again so you could see why the numbers are the way they are. Stata is Lincom. So when I say age 85 times 1, what I'm asking for is actually 1 beta 1. The variable is referring to the slope it's going to become. Plus the interaction term times the value of the moderator. So that corresponds to what I want for grip, because grip is the moderator. So I can write this out, 3 lines to get 3 slopes, or I can simplify by using a function within margins, the command dy dx. That stands for derivatives. So I'm asking for the slope of age for a range of grip strength values. So you can get a whole bunch of simple slopes with 1 line of code. And this is start at -3 in increments of 3 and go up to 3. So this is going to give me 6, 9, and 12. And these super unhelpful labels that go with it. Like, seriously, how hard would it be to just print the damn numbers that I put in here? But no. Same thing with the grip strength slope. I need beta 2, and then I need the interaction times the moderator value of age. Or I can swap out grip in here and then list the moderator values in here. And I got some pictures. So I asked for a plot of low, medium, and high on age and grip, and then threw 2 margins plots in there side by side. So let me go into here. Nope, too far. There we go. Almost got it all on one page. Yeah. So this is a plot I would show if I were thinking of age as the slope and grip as the moderator. So the x-axis is age, and the middle red line is what the model tells us, because that's when grip is 0. So we know that this age slope of minus 33.33 was significant, right? And what did we say happened to the age slope as grip increased? Do we remember? This one's less negative. So if I go from red to green, less negative. If I go up in grip, if I go down in grip, that gets me to the blue. So then you can kind of start to see where regions of significance would come into play, right? The red line is significant, is the green line. And as this keeps going up, right, eventually it's going to flip positive. At what point does it flip positive, and do I have any of those people in my sample? If the red line is significant and the blue line is more steeper, then it's probably significant too. So we're interested in finding the point at which negative turns into 0 and then 0 turns into positive. The distance between the lines conveys the other main effect. So do you remember what happened to the grip strength slope as age increased? It was positive, and it became more positive, right? So the distance in the middle is sort of the reference point for the model. As age increases, the distances increase. More spread, more positive. That is more easy to see in this picture, though. So now I've flipped what the x-axis is. This is grip. So the red line is what we got out of the model. That's for age 85. As age increases, so as we go from red to green, it's steeper. As age decreases, we go from red to blue. So the same thing here. The red line is significant. Is the blue line significant? At some point, it's going to flip to positive. So we can find the boundaries as to when that happens. I'm not going to make you do that in your homework, by the way, regions of significance, but I think it's a cool thing, and I wanted you to have an example. Okay, so that's what the next piece of output is. In order to compute regions of significance, you have to ask for one more thing. In Stata, SStat VCE gives you what is known as the asymptotic covariance matrix of your fixed effects. This is something you've never looked at ever, I bet. Like, what the hell is that? It's not a covariance matrix in the sense of like variances and covariances. This is describing the variability of your slopes and how their estimates covary. So the diagonal of this matrix is the standard error of the age, in this line, age slope squared.
Sorry, say that again?
Yep. Diagonal, where the variances would normally be, it is a variance. It's the sampling variance of that slope, the standard error squared.
Great, cool.
The diagonals are the sampling variances of your slope, standard error squared. The off diagonals are the covariances. The numbers that I have bolded here are the ones we need for the formula. We need the squared standard errors of the two slopes, we need the squared standard error for the interaction term, and we need the covariances of the interaction term with the main effects. And you're like, do I have to get my calculator out to do that? The answer is usually no. In Stata, I don't know how to do it. I'm sure someone has figured it out. But in R, I found a package called interactions, where they have a function called Johnson-Neyman. Neyman?
Neiman?
I don't know. Take a vote. I don't know, man. I'm trying here. So it says, hey, what model do you have? That one. What do you want your predictor to be? That one. What do you want your moderator to be? That one. Do you want a picture? It broke my computer. It like froze it and I had to restart. So false for now. So then it gives you this not terribly helpful explanation. When grip is outside the interval of this, the slope of age is p less than 0.05. What? Exactly. So this is my version of it. So putting it back on the original scale of grip, after we add 9, what we have learned is that the age slope will be significantly negative for grip strength of 0 up to 9.6. From 9.6 up to 18, the slope is non-significant. And after 18, it's significantly positive. So if we put that back into the picture, where'd my picture go? I lost it. I have a picture. Oh, there they are. Yeah. So this is, which one is this? Remember myself here. Age slope. Okay. So red line significant, green line not significant, blue line significant. But this would become significant after grip of 18. Like this trend would be right here. So then the question is, who in my sample has what levels of grip strength? So it worked out that about half of my sample would have a negative age slope, and for half of the sample it would be non-significant, based on the distribution of grip strength. I did the same thing for the other, switching it around, and for age, then the grip strength slope will be significantly negative for 70 and under, non-significant from 70 to 82, and significant after 82. So most of the sample is going to have a significantly positive grip strength slope. A few folks are going to have non-significant if they're between this range of age. So that way you don't have to pick arbitrary points on a continuous variable. You can find the ranges in which your slope is expected to be positive, negative, or non-significant. And here's some pictures. Ta-da! This is like ggplot Junior or something. My first ggplot, maybe like a game for kids or something. Like an Easy Bake Oven. Do they still sell those? You guys don't know what I'm talking about. I'm guessing the answer is no. They used to sell, I'm dead serious, this was a children's toy, an actual working oven that they could burn themselves with. And it was like this big, and you could make like 3 cookies in it.
I don't know if they still sell them. My sister had one.
Okay, so at one point, yeah, I never wanted one, actually. I didn't want to be like anything domestic. I didn't want to cook, didn't want to sew. I just missed that gene. But anywho, so how's this going, folks? How's it going? Any of that you want to hear again or talk about differently?
Lisa, I just understood what happened to R. I mean, it just directly gave the range, how it does change, but so what about theta? Was it the table that you just showed? I mean, it's just a bunch of tables and numbers with 0.000 something, so isn't that any other way to compute directly in theta? Is that what you're saying?
So the formula by which to use those numbers is given in the slides.
Okay.
But I don't know of a routine in Stata that does it.
I was just Googling and I'm not
Okay,
seeing
so-
anything obvious.
However, I made one in Excel. So I made this spreadsheet, actually, myself. And these are the numbers from chapter 2 from 2 different models. So you enter these things in their spots, and then it computes various intermediate quantities and eventually spits out the results. So each of these is like a whole, it's a really long, complex equation, but you can put these things in here. Chris Preacher has this on a website, by the way. Probably can't find it quick enough for our purposes, but I'll give it a shot. I believe his domain is quantsci.org or dot something. How about I just Google Chris Preacher? Let's do that. Hi, Chris, if you're listening. He's a very nice person, very helpful. And I don't even want to know what his H factor is, because then I just feel bad about myself.
As if your H index isn't present. Really?
No, he's one of those people that like, yeah, it's ridiculous. But one of the reasons is because he puts everything on a website so that people can learn how to do stuff. So we have online utilities, mediation and moderation, interaction utilities. There we go. So here's some math, here's some stuff, here's the explanation, and then here's the boxes. You fill in the estimates and then it spits it out. And I think it actually generates the R code to do it somehow. So, yeah, impressive. So, Stata folks, you can do it that way. You can use my spreadsheet, you can use this, and if I ever find a routine for it, I will let you know. I also wrote a macro program for SAS that does this, so I do have that as part of your online resources for this unit, and of course R has these various packages that will do it too. So, bye Chris. Question?
So, do you report your regions of significance in a lot of your papers?
If I would, yeah. So if there's not a specific, if the interaction moderator doesn't have specific groups that are like constraining the logical possibilities, then yeah, I would. And you can do this, let me go back for, note that I clicked a box that said there's 3-way interactions. There's extensions of this for multi-level models. It's like, oh, really? It works the same. The formulas are just a little bit uglier, that's all. So yeah. There is stuff for SPSS that other people have written. M+ has things. Oh, someone else made an Excel sheet, apparently. So, you know, various resources. But yeah, I would.
Do you see it often in other papers that you read?
No. But I think it's a lack of people knowing about it rather than anything else, which is what I'm trying to fix. I think it's cool. I think it's useful. Okay, what if, switching gears, okay? Back to the slides for a minute. 22 is where I'm at. What if I had more than one interaction in my model at the same time? We looked at this before, right? You're like, we did? Like, it was like a week ago. But if I have x and z in this example and w and z, then beta 3 for the slope of z, because it's conditional on both things, is specifically when both moderators are 0. The other interactions are the same. What if, here's the ingredients for how you would get the simple slope for z. It has both of these things in it, like that. What if you have a categorical predictor? So in this slide deck earlier, we had an example of treatment group with 4 categories, and I had created 3 dummy codes to contrast the control group as the reference relative to each possible type of treatment group I have here. Okay, so I have to put all 3 of these dummy codes in the model to differentiate my 4 groups, right? If I want to differentiate my 4 groups, I need 3 slopes and an intercept. Sound right? What if I want to know if the effective group depends on how old you are? What if treatment 1 is more effective for older people, but treatment 2 is more effective for younger people? Might that be of interest? Yeah. So how many interactions do I need if I want to answer that question as to whether group differences are moderated by age? That's one interaction conceptually, right? But how many actual slopes does it take? A softball question. Don't think too hard. 3, yes. Like that. So this model has 3 simple main effects of group, 1 simple main effect of age, and then 3 interaction terms. So that means beta 1, beta 2, and beta 3, who are they group differences for? They're conditional. They're going to tell me about group differences in what kind of person? Okay, I picked on this side of the room already. Sir, in the back, what's your name again? Melvin? Elvin. Okay. What are these 3 differences conditional on? What kind of person? Different categories of age? Yes, more specifically? When do these interaction terms drop out? At what age? When do they go to 0?
85.
Yeah, 85. You got a friend you phoned here. And I didn't even see you pick up your phone, so that's really impressive. Yeah, these are now conditional group differences at 85. Likewise, who is this the age slope for? Anybody?
Control group.
Control group, yeah. So same premise, just conditioning on more things at the same time. So conceptually, this model really only has group and age and their interaction, but that takes 7 slopes. So we might want to do a couple things here. To answer the question, does the effect of treatment vary by age? I need a hypothesis test for 5, 6, and 7 at the same time. That's a test statement in Stata. That is a GL, HT, and R. However, the model is going to tell me treatment differences at any age and group differences at any group differences at any age differences for any group. So here's what it would look like. This is the 3rd model in your homework. I'll just tell you that straight out. So the rules are the same. If I want the slope of age, I go into the equation, I find all the terms that have age, I factor that out, and then the ingredients of what's left tell me how to get the age slope in any group. So if I want it for the control group, that's just beta 4. If I want it for the treatment group, I need the slope for what age is in control plus beta 5 for how it differs. So this is something that folks often get confused by. I want to draw attention to. Beta 5 is not the slope in the treatment group 1. It is how the slope in treatment group 1 differs from what it is in the control. Interaction terms are differences in slopes. So to get to the full slope for what it would be in treatment 1, I start with beta 4, what it is in control, plus beta 5 for how it differs in treatment 1. And together I get to treatment 1. Likewise, to get to treatment 2, I need to pick up beta 6 instead as the difference between treatment 2 and control, and then I need beta 7 instead. How about group differences at any age? Same premise, simpler equation. And then treatment differences at any age, a little bit uglier, but still solvable. So I have in this example 1, a 2x3 problem. So we're going to treat gender as continuous for the purposes and do 3 groups, or 2 groups. You get a chance to practice 4 for this. I don't want to do 3-way interactions, but just don't be scared of them. You know what 3-way interactions do? They take 2-way interactions and make them more positive, less positive, more negative, or less negative. Do you know what 4-way interactions do? They take 3-way interactions and make them more positive, less positive, more negative, or less negative. It's the same. You just keep going up. Now, putting the words on it can be a little tricky, and at that point you absolutely need a picture. But you should not be afraid of 3-way interactions. So I'll let you read about those in chapter 2 if you want to do that. But here's the math as to how you would get the model implied main effects, and this is really what they'd be called, a simple 2-way interaction. Like seriously. Not simple. That's just mean. There. Okay. Let's look at the model that has 2 interactions so that we can answer the question, does the effect of gender vary by dementia group? And does the effect of dementia group vary by gender? Here is a table of model predicted means that is going to help us understand what this equation is doing. These are conditional means for somebody who is 85 with a grip strength of 9. Okay, so we call those adjusted means sometimes, or conditional means. Those are the 6 numbers that I care about. So in this context, if I'm interested in the gender difference, I have 1 gender difference for each group, right? One way to think about this interaction is whether this gender difference is different than that gender difference. Interactions are differences in slopes or differences in differences. The latter is a term that's used in the causal inference literature, I think. You talk about that? Differences in differences? Yeah, same premise. So I'm going to do the math. What's 29 minus 26? I think that's 3, right? Can we get a judge's ruling on that? 3-ish? Cool. What's 23 minus 20? 3. So I don't think there's an interaction term here. What about you? I don't have any standard errors or anything around this, but I'm just going to do a visual analysis and say it doesn't look like it. Okay, so what if I did this 3, and now I compare the gender difference in the current group, ruh-roh, raggy, that's like 11. So is 3 as a difference the same as 11 as a difference? Probably not, no. That's an interaction term. So one way to think about it is the gender gap differ by group? I can go the other way. How about dementia being bad for you? Is it always bad for you? Is it equally bad? So if I'm a dude and I don't have dementia, I have a 29. If I'm a dude who does have dementia right now, it's 17. I believe that is 12. Judge's ruling? Okay. How about this one? 26 versus 6, that's about 20. Is 12 different than 20? Probably. So that's another way we can look at the interaction, is from that perspective. But for this one, I could do, does the difference between these two differ between these two, or that one or that one? There's 3. So the omnibus interaction tells me about these 6 cells. It doesn't actually answer any questions. To do that, you need to dive into the pairwise slope differences. So there's 3 implied interaction terms here. Not 1, there's 3 that are implied. To get them, I only need to get 2 parameters, and then the third is a linear combination of the missing 2, whatever one is missing. In ANOVA language, did your previous coursework or previous research experience talk about like marginal main effects and stuff like that in ANOVA land? That sound familiar? Those are out here. So this is using equal weights to average across the groups. You don't have to do that, but most of the time that's what happens. Like 27 is what you get when you average over men and women who don't have dementia. 21 is what you get when you average over men and women who are going to get dementia, and so on. Likewise, 23 is what you get when you average over all the kinds of dementia for dudes. 17 is what you get for chicks. I don't ever like marginal mean comparisons. So the default main effects you get out of an ANOVA output to me are useless, because they're answering this question. Do those means differ? And do those means differ? So if I look at this one in particular, I'd be like, well, 23 minus 17 is, that's a little trickier one, still 6. Okay, I think I'm good. Now, if I look at this table, is there anybody where 6 is the expected difference? For what kind of person would I expect to see a difference of 6 between genders? We already established 3, 3, 11. 6 doesn't apply to anyone. So why would I care if there's a mean difference here? Same complaint out here. So I don't bother with marginal mean tests at all, because I don't think they're useful. Everything you want to know is inside the cells. You just got to know how to ask for it. Do you want to look at some results? Give it a shot? Let's do R, because I didn't print the output for Stata in this one. It's in the online documents though. So I'm stacking up more interaction terms here. Gender by dementia group. Okay, let's go. Intercept. Has it changed what it means relative to any of the other models we've seen today? Nope, haven't added any new predictors. Age and grip, have they changed what they mean because of our 2 new interactions between gender and dementia group? Nope. These, have they changed? Yeah, they're conditional on the interacting term being 0. How about the age by group interaction? Has that changed what it means? No. The only part would be maybe after controlling for a couple more terms, but otherwise it's the same. So let's start here. This is 1 gender difference out of the table. Which group is it for? It's when both of the interaction terms involving it are 0. Who's the 0 group in dementia status land? Don't have it, yeah, none. So this is -3 is how women differ from men as the reference, specifically in people without dementia. What happens to that gender difference? We highlight just the two numbers we need in people that are going to get dementia. Which pattern is this? This is less negative. Now, what do I do with the 6.16 as the coefficient? Okay, we got a couple people who haven't talked yet, I think. Who hasn't talked? I think that row. What do I do with the 0.16?
So the gender difference was about -3. Oh,
Yeah, I got someone struggling, but I think she wants you to help, right? Because she's feeling shy.
For women, those who are going to have dementia in the future, the slope for women are less negative.
Yes, by 0.16. That's it. Because we don't have to do per unit anymore because a unit is shifting to the other group. So the negative slope favoring men is less negative by 0.16 in future dementia. That's it. So 0.16 for the interaction term is how the slopes differ. So to figure out what the slope is in the future group, we add those two numbers together. What about the gender difference in people who already have dementia? Okay, Zoomers, you want to try? Sorry, you want to try?
yeah, so it is becoming more negative.
More negative, bigger.
So the gender difference was starting from -3, but now it is becoming -3 and then -7, so -10.
Yep, minus 10-ish is what it would be together. Yep. How about the gender difference in, let's see, do I want to do that one? No, I don't want to do that one. Let's go the other way. This is the dementia group difference between none and future. End of sentence, or do I need to keep talking? Keep talking. Who hasn't talked yet? Person behind you, what's your name again? James, okay. I think you haven't talked yet. So he told me to keep talking. I'm going to tell you to keep talking. This is the difference between none and future. ... What's the end of my sentence need to be? Conditional on when the interaction terms go to 0, which happens for what value of the interacting predictor here? Which group? The first one, men. Yep. So this is the difference between none and future, specifically in men. How do I get to what it would be in women?
You have the interaction effects.
Which one?
Since this is for future use, so we have the for future interaction effects.
That one. Which pattern is this? Oops. It's -6 in men. What happens to the -6 in women? Less negative. Is that a bigger difference or a smaller difference? Smaller, weaker. So being a chick is a protective factor against dementia by a tiny little amount. How about None versus current. Dementia is bad for you, right? This is the dementia group difference in men. What is it in women? A lot worse. Much more worser. So we don't know from the output what happens to future versus current, right? Can I ask for it? Yes, I can, and yes, you shall. So here's a pro tip for your homework. Any question that asks for something involving a reference group is already in your output. Any question that asks for something for not a reference group, you got to ask for. Comparisons among not the reference group are linear combinations. So let's go get them. First thing I might want to know, is there an interaction that I should be interpreting? So I might lump together my two interaction slopes. There are two different ways to think about what that hypothesis test is telling me. The more obvious interpretation is that this is the omnibus test of the interaction. Does group moderate the gender gap? Yes or no? Those two slopes lumped together are the answer. But another way to think about it is because those are the two terms that we just added to the model, this is also simultaneously the F-test for the change in our square. It's the same. So you list in here whatever slopes you want to test and set them equal to 0, and then it spits out your F, the degrees of freedom, numerator, first denominator, and then the p-value. So yes, there is an interaction term. I'm going to skip these two for right now. Here's a picture we're going to head to. So I'm using the prediction function to get predicted outcomes from a range of values. I am setting age and grip at 0 because they're not going to be part of my picture. I'm focusing on the other interaction. And I wanted values ranging from 0 to 1 for each of my dummy codes. Cool? Now, however, it gives me some rows that are impossible because it's doing all possible combinations. But you can't have somebody who both has future dementia and current dementia. So these are numbers, but they don't mean anything. So what I did in the next code is take this information, save it to a data frame, get rid of those rows, do some labeling stuff to make a picture with, and then we get the picture. So I know these are line graphs, and it's not the best choice potentially for categorical data, but just bear with me. ggplot Junior can only do so much, all right? So if I have a dementia group 1, 2, or 3 here, that was the original coding, and I have different lines for gender here, you can see much more clearly what the pattern is. So there is a gender gap, no matter who you are, right? The red line is below the blue line, always. Whether it's significant, we don't know because of the differences in sample size. But the pattern is such that the gender gap grows in people who already have dementia. That's one way to think about it. Or if we go the other way, that the effective dementia is much worse in women. The blue line is fairly straight, the red line falls off the cliff. And then here's the same information using gender as the x-axis instead. So in this case, we would not do regions of significance because these variables have a limited set of possible values. So I would ask for this slope, this difference, the same thing for blue, that difference, that difference, that difference. Those are the only logical possibilities. So that's what we're going to do. And unfortunately, it looks like this. So these are in order. You got to know your order. So the pattern is, if I want the sex difference, I turn on the beta that goes with that. If it's for the no dementia group, then my moderators are zeroed out. If it's for future, I turn the first one on. If it's for current, I turn the second one on. If I'm doing the dementia group differences, then I turn on the relevant main effect and then turn it on for women, the other main effect and turn it on for women, and then there's the model implied differences. So here's how I got the last two lines with the minus ones and ones. I literally subtracted. If I want future minus current, or future current, it's actually current minus future. So if I do that line, actually, let me go up here. Where is it? No, I didn't write it out, I think. I want none versus future. This one minus that one. There we go. Got it. Got it, got it, got it. There we go. I did do it. Okay. So I'm subtracting this one on top and then subtracting this one from it. So the first one stays 0. What is 0 minus 1? See, those of you who haven't talked yet, now's your chance. What's 0 minus 1? Minus 1. What's 1 minus 0? 1. What's 0 minus 0? 0. Yeah. So if I do then the other one, 0 minus 1, minus 1. 1 minus 0, 1. So you already have the ingredients to figure this out. Last but not least, the interaction terms. The first 4 lines I wrote out for pedagogical purposes only. I didn't need to write this. The first interaction I get out of the model answers these 2 questions simultaneously. The second one answers these 2, and the third one is the difference between those 2 interaction coefficients, minus 1, 1. So there's actually 3 different interaction slopes that this model is predicting. It gives me 2 by direct, and I ask for the third as a linear combination as the difference. And then the results are down here, which we can look at next time. And we'll re-go over some of this too. How's that sound? But now you have enough to do your whole homework, if you want. All right, questions as we wrap it up? Yes?
It's not a question, it's an announcement.
An announcement, okay.
I need to shift back my office hours tomorrow by an hour. I'm sorry, friends.
What were they supposed to be? Remind me?
10, I think. I've got a doctor's appointment and
Okay.
I should make it, and I don't want folks chilling waiting for me, so.
Okay, can you post an announcement and icon too in case folks aren't there? Okay. All right then, so please do your first formative assessment by Monday night. Let me know if you need anything, and thanks for being here. I'll see you next week. Bye, Zoomers.